Good morning, everybody. It is Thursday morning. What is it? 11:17. Yeah, hold on. Oh, I'm not prepared. Where's my pens, pencils? Hold on. So sorry, everybody. No recording, and I'm starting the lesson. I'm not even prepared. Gotta find a pen. I thought I had a pen in my hand. I do. I got a pen. Okay. So here we go. Sorry about that. 11:19, huh? Yeah. So, logarithms. Let's keep going with logarithms. Logarithms sound hard, but they're really not. But let me go ahead and write this down. So we know that if we have some base to an exponent equals some answer, like an example, if I have 10 to the third power equals 1,000, right? We know, right, that we can rewrite that in what we call log form. We rewrite as log of the base of my answer equals my exponent. Okay, so then in this case, right, hopefully you have that. We talked about this Monday, Tuesday, right? Okay, that then we can rewrite this as log base 10 of 1,000 equals 3. And sure enough, even if you use your calculator, it will verify what I'm saying. In fact, check it out. I know that 10 to the third is, but log base 10, so log of 1,000 equals 3. So what are logarithms? They are exponents. So logarithms are exponents. Logarithms are exponents. Yeah, whatever, Mr. Davies, big deal. No, it really is a big deal because then logarithms have rules. And the rules about logarithms are the same rules that are about exponents, okay? So, example. Let's start right off. First rule, and that's the product rule. If we have log of some base, any base, of some expression m, I like m, times n. Okay, so if these are exponents, they're going to follow exponent rules. So you can rewrite this as log base b of m plus log base b of n. Or when we multiply bases, we add their exponents. Okay? You won't really, this is something you will definitely do in calculus. You won't do a lot of it. We'll do it in pre-calculus also, but we need to know these rules. Okay, the quotient rule. If I have log base b of some m divided by n, okay? Again, logarithms are exponents. So if I have two bases and if I divide the bases, then what happens is I subtract the exponents. So I'm going to go log of base b of m minus log base b of n. And the proof to this is in our journal if you guys want to check it out, okay? Now the power rule, okay? If I have log of some base b of some expression m to the power of any power. So we're going to say p, any power, like a power, like its own exponent to the power of p, right? Then we know that an exponent to an exponent, you multiply the exponent. So we're going to have p times the log base b of m. And we're going to show you how all these work in just a little bit. We just want to write these rule downs. Now finally, the change of base. Change of base comes from this. If I have log base b of m, okay, now hold on. Before we go any further with this, we can do log base 10 of any number because base 10 is in our calculator. Base 10, right? Log. That's log base 10. Okay, we can do that in our calculator. Okay, that's called common log. And I can do a log base e of anything because that's like a natural log. And again, natural log. That's also in our calculator right there, okay? What makes it difficult for us is if we don't have the base of either 10 or e. So if we have this, we can change it to common log. We're going to change this to common log I'm going to change this to common log, and I'll show you what we're going to do. I'm going to change it to common log, which is base 10, okay? So we're going to rewrite this as log of m over log of b. And this is invisible base 10, invisible base 10, okay? So, as an example of this one, I want to show you. As an example, we'll show it later. Example. If we want to do log base 3 of 20. It's like saying 3 to what power? It's like saying 3 to what power equals 20. Well, guess and check, 3 to, oh, let's see, 3 cubed, 3 to the third is 27, 3 squared is 9, so the answer's got to be 2 point something, right? So you can guess and check, guess and check, and guess and check. Now, some of you might have a fancy button on your calculator, log base 3. Some of you can do this, but if you can't, you just do this. You're going to go, you ready? You're going to go and rewrite this as log base 20 divided by log base 3. And I'm going to use my calculator. So I'm just going to go like this. I'm going to go log, that's my common log, of 20 divided by log of 3. I get an answer of about 2.7. I knew it was close to that. So if I went 3 to that power, right? Yep, back up. 3 to that power 20. Okay? So if you don't have a super fancy calculator or some kind of software that does different bases, you have to change it to base 10. Because base 10 we can do on a normal calculator. You can use common log. Okay? Alright, let's keep going. So example 1. On example 1, what we want to do is use these rules up here. Okay? Let's see. So it says expand. It says expand. What does that mean? Well, what I have are invisible multiplication up here. I got a times and I got a times, okay? You don't see them, but they're invisible. So I know that if I have a log of two things being multiplied, I can separate them by addition, okay? So I'm going to rewrite this as log base 3 of 2 plus, because if it's multiply, I separate them by plus log base 3 of x plus, because there's a times here, and if I'm multiplying I can separate them by a plus log base 3 of y to the 4th power. Now, if I see multiply in between, I can separate the logs by plus. This is really handy in calculus. Now, I'm going to do one more trick on this one. I'm going to apply now this rule. So if I have a power, I can float the exponent down. I'm going to bring this 4 down here. So I'm going to use this rule here. I just bring the exponent down. So I'm going to rewrite this as 4 log base 3 of y. I just brought the 4 down. And so an exponent to an exponent, we float the exponents down. It's a really handy trick that you're going to need in pre-calc and calc. So now let's go ahead and finish it. I got log base 3 of 2 plus log base 3 of x plus 4 log base 3 of y. Okay, now let me go ahead and highlight that because that's the answer. That is expanded. Okay, that's expanded. Okay. Okay, example 2. Let's expand example 2. So the same thing. ln, still log. I see a times in here. It's an invisible time, so I'm going to apply this rule up here. I'm going to write ln of 3 plus, because there's a multiplication here, you don't really, it's invisible. So if I multiply, separate my plus ln x squared. Now, because this is a divide by, I'm going to subtract minus ln, because that's my log, of y. Okay, so I saw times. If I see a times, I separate with a plus. I see a divide, I separate with a subtract. Now the last thing I want to do is I have this x squared. I'm going to float it down. Okay. because I'm going to use the power rule. So bring down the 2. So my final answer would be ln of 3 plus 2 ln of x minus ln of y. Okay, that is my expanded version. And when you get to calculus, boy, I'll tell you, this is really going to be handy in calculus. Okay, now let's go and do the opposite. So the opposite says condense. So we're going to rewrite it as a single logarithm. Okay, so what we want to do is just the opposite. First of all, these right here, this 3 was an exponent that got floated down, so we're going to bring it back in. This 2 was an exponent, so we're going to bring it back in and float it back in, okay? This 5 was an exponent, so we're going to float it back in and bring it down, okay? So let's rewrite this as log, and the base is 10 because it's invisible, of x cubed, because I brought the 3 back in, plus log base 10 because it's invisible of y squared because I brought it back up and in, minus log z, bring the 5 back up and in. Okay, now I'm almost there. Single log, single log, single. So I want to write log base 10 of. So let's take all of these and bring them in. Okay, so how do I do that? Well, if it's plus, I can bring them together as times. Okay, so I'm going to do just the opposite. We'll go x cubed times, you don't need the times sign, but I'm going to put it in there anyway, times y squared divided by z5. Okay, let me highlight some things so you can see it. Okay, here's my plus, brought together is my times. Here's my subtract, brought together is divide. And that is writing as a single log. You don't need the times sign, but there it is. Okay, all right, let's turn the page and see what we got on the other side. Okay, now example 4 talks about log base 3 of 12. Now, if you have a super fancy dancy calculator, which I think I do somewhere around here, it'll do it. But if you don't have a fancy dancy calculator, then you can't. Come on in, Austin. I'm teaching right now, but come on in. I'm almost done. I'm really close, okay? So if you have a fancy dancy calculator, what you can do, if you have one, log base 3, so really we're saying, okay, 3 to what power equals 12, right? Well, we can guess and check. We know it's got to be bigger than 2 when it's 2 point something, right? If you have a fancy dancy calculator, which I do, I'm going to go like this. I happen to have one in my math. But most of you don't have a fancy dancy calculator. Log base. So I can go log base 3 of 12. And my fancy calculator will give me the answer about 2.26. 2.262. Okay, so x is approximately equal to 2.262. Okay, now most of you might on your phone have a log button. You know how you switch it around, you'll have a log button, but your log button on your phone is log base 10. So if you go to your phone and you see your log button, it's base 10. So how do you do this if it's base 3? You don't have a fancy calculator to do base 3. Well, you just do this. You go log of 12 divided by log of 3. Now, if you have a basic calculator on your phone, so your cell phone will work, you could just go log 12, close the parentheses, divided by log 3. Hey, I got the same answer. What do you know? Okay, so if you have a fancy dancy calculator and you can do any base, awesome. But if you don't, you'll at least have on your phone base 10, so you can do it log base 10 of 12 divided by log base 10 of 3, and you get the same exact answer, okay? All right, now, last but not least, 5. Guess and check. Well, 5, let's see, 5 squared is 25, 5 cubed, let's see, 5 squared is 25, I know 5 cubed is 125, so it's probably got to be about 3 point something. Well, I don't want to guess and check. What I want to do is this. First, let's change it to a log, because logarithms solve exponents. Logarithms solve exponents. So I'm going to rewrite this. I'm going to go log base 5 140 equals x. Okay, again, if you have the fancy dancy calculator, boom, you just go, okay, I can do that. I go, all right, Oh, that's not the one I want. So if you have this super cool fancy dancy calculator, you could go straight to log base 5 of 140. Boom, you get the answer. About a 3. I knew it was 3. So I get x to equal about a 3.07, blah, blah, blah. Okay, approximately. Okay. Now, if you don't have a fancy calculator that will do in any base, then at least on your phone you have a log button. Again, check your phone, but you have a log button, but it's base 10. So you can still do this, but you have to go log of 140 divided by log of 5, and you can use your phone or any basic calculator to do this. So if I just went log 140, now that's log base 10, right? Close parentheses divided by log base 5, I get the exact same answer. Okay? So again, most of you will not have a fancy button on your calculator unless you have an expensive calculator, but you all should have a log button on your calculator. Okay, so that's what I have, and we'll talk about this some more during our Zoom meetings. So that's all I got.